Cell potential of a galvanic cell. The galvanic cell that we saw earlier used a zinc anode and a copper cathode. A spontaneous chemical reaction converts chemical energy into electrical energy. An electrical current is produced, as shown by the deflection of the ammeter. If we connect the terminals of a voltmeter to the two electrodes, we see that there is a potential difference between the ends, which drives the flow of electrons from the anode to the cathode. This is the cell potential of this zinc-copper galvanic cell. It is also called cell voltage, or the electromotive force, EMF, of the cell. The direction of conventional current is the opposite. The voltage depends on the concentration of the Zn2+ ions in the oxidation half cell and the concentration of the Cu2+ ions in the reduction half cell. It also depends on the temperature. If the conditions are standard, that is, all ionic concentrations are 1 molar, the temperature is 25 degrees Celsius and the pressure is 1 atmosphere. The reading on the voltmeter will be plus 1,1 volt, provided that its positive terminal is connected to the electrode at which oxidation takes place, and the negative terminal to the other electrode. We are using a very sensitive voltmeter that measures voltage in millivolts. As long as the cell potential is positive, there is a flow of electrons in the external circuit. As the galvanic cell is used, the concentration of the Zn2+ ions and the Cu2+ ions change. Also, the anode will slowly lose mass, since zinc dissolves there. The cathode will slowly gain mass, since copper is being deposited there. The cell potential decreases until it becomes 0 when the concentration of the Cu2+ ions is too low, or if the zinc anode is completely used up. The cell has completely discharged, or has gone flat. The cell potential depends on the chemicals that are used. If we use another metal, like lead, Pb, and its salt solution instead of copper and copper sulfate, the cell potential will be different. Note that 1,1 volt, produced by a standard zinc-copper galvanic cell, is a small voltage that cannot power most devices. So we normally use a series of cells to give a voltage of 3 to 5 volt to power modern phones, tablets, etc.
Starting to feel it? Now go master it with Maski.